Well, welcome to math today. We're going to learn to convert metric units of measure. It's called the base 10 unit. Write this down with today's date and page number before moving on. All right, here is your warm-up today. This is obviously how you're going to be doing the work today by multiplying up or dividing up or multiplying down. I want you to solve these by multiplying by 1,000 and then dividing by 1,000 for 3 and 4. Come back when you're done. Here are the answers you should have gotten. Just multiplying up, you go from 0.0042 to 4.2. And all you had to do was just move the decimal point 3 times to the right. And with 3 and 4 dividing, you move it 3 times to the left. So as I said, the metric system is a value that is a system that it basically shows the value of things moving up and moving down by timesing by 10 or dividing by 10. So if you're ever moving the decimals, or if you're ever moving conversions up the steps to larger values, you divide. If you're moving down the steps to show the teeny tiniest values, you have to multiply each step. In the center, everything basically starts with meters, grams, or liters. But sometimes you start at any step, and you have to kind of move up or down. I want you to put this drawing in your notebook so you remember these steps, and this is how we're going to try to solve the first couple sections of this lesson. All right, so here's a sports application. Let's say we were looking at a high jumper that cleared the height of 1.75 meters, but we needed to measure it in centimeters. So what do? Well, here are your steps. The first thing you're going to notice is a centimeter is actually 2 places to the right of meters on the chart. And since it's to the right, that means we're going down the steps, so that means we have to multiply. So this is one step, and this is the second step. Or 10 times 10, or 10 squared, is 100. So basically now we know that to go from meters to centimeters, we're going to have to multiply by 100. So you take 1.75, you multiply by 100, or just move the decimal point. We'll say this is 2b and this is 2a. Or you just move the decimal point 2 places to the right. And 1.75 meters converts to 175 centimeters. Both are worth the same value, just written differently. So you can see here with the metric unit, it's a lot easier than the customary unit because it's just moving the decimal point along the number you have. If it's getting smaller, like going towards centimeters, you multiply by how many steps. If you're getting bigger, it just goes the other way. All right, here's what we mean. I'll do one and then you're going to do the other. Unless you want to do both, stop the video now. So the length of a school hallway is 115 meters. So how many kilometers is the hallway? Well, if we're looking at our steps, here's meters. Then it goes up to decameters. Then it goes up to hectometers, CTO, and then it goes up to kilometers. So we're going up 1 to 3 steps. So that means 10 times 10 times 10, which is 1,000. But since we're going up equals divide, down equals multiply. So we have to divide by 1,000. Which means we have to move the decimal point over 3 times to the left. Once, twice, 3 times gives us an answer of 0.115 kilometers. That's how you get the answer. Go ahead and work on number 12. When you're done, come on back. We'll see if you got the right answer. So with this one, we were going from 300 milliliters and we're trying to go to liters. So again, we're going up the steps. So we actually had to go up 3 steps, so that's times 10, times another 10, times another 10, which is 1,000. But since we're going up, that means we had to divide. So you have to move the decimal point over once, twice, 3 times. 0.3 liters is what you should have got. If you did, come on over and give me a high five. All right, without using the words, let's just simply look at some problems here. So if we had to convert CDs from a CD case of 17 or 14 centimeters wide, and we had to bump it up to meters, remember, all you're doing is you're noticing that 100 centimeters equals 1 meter. Well, for that case, that means we're going to have to move the decimal point twice, because the unit is actually getting bigger, which means the number becomes smaller because it's bigger chunks. So we have to move the decimal point 2 places to the left, and when you do that, 14 to the left, 1, 2, the answer becomes 0.14 meters. 14 centimeters and 14 hundredths of a meter, same value, just showing it in different measurements. Write this down if you think you need to in your notebook. Okay, let's look at another couple here. So here we have a ball of clay, it's 4 kilograms, and we want to know how many grams it is. Well, we're stepping down the stairs 3 place values, or 3 steps. So that means we have to multiply by 1,000. 10 times 10 times 10 is 1,000. So 4 times 1,000 gives you 4,000 grams. 4,000 grams when you multiply them. Let's say you had a bottle of water that contains 8/10 of a liter, but you want to know milliliters. Again, it's 3 steps down, so you're multiplying times 1,000, and all you got to do is move the decimal point 3 times. 1, 2, 3, and you fill in those gaps with zeros, and that's how you get 800 milliliters. Again, if you think you need to write this down in your notes, you can. If you don't think you need to, don't worry about it. So here are 4 more problems I want you to work on. Remember, think of those steps. For the first one, it says the diameter of a ceiling fan is about 95 centimeters. So centimeters to meters is 3 steps. So when you're doing the steps, you're going to have to move over from centimeters to meters. It's actually 2 steps. Centa means 100. That means we got to move 2 steps up, which means we divide and you get 0.95 meters. Go ahead and do the next 3. Come back when you're done. And here are the answers you should have gotten for these problems. For number 3, we are stepping up to make the number smaller, as far as the value greater. And for 4 and 5, we had to step down to show smaller values for those bigger versions. Now, the last step, or the last section we're going to look at, I want you to write down this table. This is one of those things I'll be looking for as well. Distance, mass, and capacity, these are the 3 most common areas, and these are the most common conversions you'll have to do. If you have these conversions written down, you can do proportions really easy. So have this written down before moving on. I will be looking for this at the end. All right, so let's say we're looking at this, and we're looking for a conversion factor. Now, we know, oh, factor spelled wrong, oops. We know that 16 meters equals some centimeters is going to be a value. We know that for every meter, it's 100 centimeters. So all that means is we have to multiply by 100. So you multiply the 16 times 100, you get 1,600. That's how you get centimeters. This works really easy when you can have a conversion table and you can see that 1 meter equals 100 centimeters. It makes it easy to do that. Write this down if you think you need to. And my favorite method that I use for almost all these conversions, whether it's customary from last unit or metric, is the proportion method, which is grams to kilograms. Now I know that every 1,000 grams equals 1 kilogram. That's my first ratio. When you add another ratio next to it, you make a proportion. We put what we do know, which is 450 grams across from grams, and we're solving for kilograms. 1,000 times x is 1,000x, and 450 times 1 is 450. Then all we have to do is solve for x, so we divide both sides by 1,000. And 450 divided by 1,000 gives you 0.45 kilograms. Again, if you want to write that in your notes, go ahead.